How many ways are there to seat 4 of a group of 10 people around a circular table where 2 seatings are considered the same when everyone has the same immediate left and immediate right neighbor? You have 3 minutes. When approaching this problem, it's important to consider that there are 2 distinct subproblems which must be solved independently to arrive at our final solution. The first subproblem is to count the number of ways that we can select 4 people from our original group of 10. This can be simply done in 10 choose 4 different ways. The second subproblem, however, asks us to count the number of ways that we can order the chosen 4 people at a table, according to the description given in the question. Let's illustrate what exactly this means. It's important to note when solving this problem that the following 2 are identical when counting the number of ways to order our 4 people. And the reason for this is because to the left and the right of each of the 4 participants at this table, they have the same corresponding neighbor. As a result, these 2 counts would be identical when solving this problem. There are 2 approaches we can use to solve and count the number of distinct orderings of people at this table. The first would be by fixing one of the people at the head of the table. Let's designate person A as the current head. And what we would then do is count the different number of orderings for the remaining 3 people, B, C, and D. Now, because each of B, C, and D can be placed at each of the 3 remaining positions, and the 2 remaining people after that can be placed at 2, leaving 1 spot for the final person, there are 3 factorial ways to order B, C, and D after fixing A. And of course, by symmetry, the same logic holds if we were to fix any of the other 3 people at any of the other 4 remaining spots. The second way, however, to count the total number of orderings of our 4 people would be by not fixing anyone and allowing each of the 4 people to take up any of the 4 spots. So A could go to 4 spots, B could go to any of the 3 remaining ones, C to 2, and D to 1. And what this would give us would be a total of 4 factorial orderings. However, it's important to note that in this method of counting, we are assigning these 2 counts different and distinct orderings of our people, when we know for a fact that this is not true. In this method of counting down here, where we get 4 factorial, we are allowed to select this as the first spot for A, or that for the first spot of A, and so on and so forth for B, C, and D. And as a result, we end up getting this duplicate count. However, for any of the possible orderings, let's say this one in particular, we know that there are 4 duplicates, or 3 additional duplicates, I should say, because A can be rotated to any of the 4 total spots. So to get the number of valid orderings, discounting the additional duplicates, we would divide out by 4 for the 4 total spots that person A could sit at. And this, just like we would find using the first method, would yield us 3 factorial total ways. Now, combining parts 1 and 2, subproblems 1 and 2 of this problem, we get our final solution of 10 choose 4 times 3 factorial. Thank you for watching. Thank you for watching. If you enjoyed the video, please like, subscribe, and check out our parent site, OpenQuant.co. Of course, if you have an alternative solution, please comment it below. We'll pin the best one. Thank you.